When you think about how MySQL just completely took over the database world, you might think it was because of some single killer feature. But the truth is, its real genius, its secret weapon, was something way more interesting. It was built on the power of choice. And we're going to dive into how that one architectural decision pretty much shaped the internet as we know it. This really gets to the heart of a problem that developers have been battling for ages. Can one single database really be the perfect tool for every single job? I mean, think about it. The needs of a simple blog versus a massive telecom network. They're worlds apart. Well, MySQL's answer to that question was a hard no, and that's where our story really kicks off. So, the big idea, the core innovation inside MySQL, was its pluggable storage engine architecture. The best way to think about it is like a toolkit. Instead of just giving you a hammer and saying, good luck, MySQL gave you a whole toolbox. You got a hammer, a screwdriver, a wrench, and you could pick the exact tool for the specific job you were doing. This was an absolute game changer. And the first major tool in that kit was MyISAM. For years, this was the default engine. It was the original workhorse that powered the insane growth of the early web. It was built for a much simpler time, a world where websites were all about reading content, not constantly writing or changing it. And this right here shows you the trade-off. MyISAM was blazing fast and super lightweight. For a blog or a forum, you just couldn't beat its speed. But that speed came with a price. It had no idea what a transaction was. So if a process failed halfway through, your data could be left a total mess. And crash safety? Yeah, that wasn't really on the menu. This is exactly where MyISAM was the perfect fit. Just picture the web in the late 90s, early 2000s. It was all about consuming content. For those kinds of read-heavy sites, or having perfectly consistent data wasn't a life-or-death situation, MyISAM was the undisputed king. But of course, the web didn't stay simple for long. A new giant was waking up, e-commerce. And all of a sudden, data integrity wasn't just a nice-to-have feature. It was absolutely critical. You can't just lose a customer's order. The web needed a new kind of engine, one that was built from the ground up for reliability. And that's when InnoDB stepped onto the scene. InnoDB was the answer to all of MyISAM's weaknesses. It brought full ACID compliance to the table. That's the gold standard for guaranteeing your data is safe. It had real transaction support, so if an operation went sideways, it could just roll everything back safely. It could even recover from a crash. This was the grown-up, business-ready engine that, no surprise, eventually became the new default. Okay, let's make this real. Imagine a customer places an order online. The system has to do two things: update the inventory and record the sale. With MyISAM, if the inventory update works but the sales record fails, you're stuck. Your data is now wrong, it's inconsistent. With InnoDB, the entire failed transaction just gets rolled back, like it never even happened. Your data is completely safe. That's the difference, and it's huge. And this is exactly why, for any application where you absolutely cannot mess with the data, we're talking online stores, banking systems, any serious business application, InnoDB became the only choice. It traded a tiny bit of MyISAM's raw speed for something way more valuable: trust. But what if just being reliable isn't enough? What if you have a system that can never, ever go down? For that kind of mission-critical job, MySQL had yet another specialized tool in the toolbox: the NDB cluster engine. Now, NDB is a completely different beast. It's a distributed system where your data is copied in real time across multiple machines. If one of those servers just dies, another one instantly takes over with zero downtime and zero data loss. This whole setup is designed for what's called 5 nines of availability. That's 99.9999% uptime. So where on earth do you need that kind of insane resilience? Well, think about the systems that our entire modern world runs on. The telecom networks connecting your calls, the core financial systems processing millions of transactions, or massive online games with thousands of people playing at once. These are the places where NDB cluster absolutely shines. So as we look back at these completely different engines, this really clear pattern starts to show up. See, MySQL didn't win by being the best at one thing. It won by being able to be many things. It adapted not by changing its core, but by always adding the right new tool to its toolkit. So here's the snapshot, right? 3 different engines, each perfectly suited for a different era and a different problem. You had MyISAM, all about speed and simplicity. Then InnoDB, focused on rock-solid reliability. And finally, NDB cluster for when you absolutely positively cannot go offline. It was always about having the right tool for the job. And what's so cool is you can literally map the evolution of these engines to the evolution of the internet itself. The early web needed speed, so MyISAM was there. The e-commerce boom demanded reliability, so InnoDB stepped up. And the always-on era required constant availability, and NDB was ready. MySQL evolved right alongside the web. And this gets us to the ultimate takeaway. MySQL's greatest architectural achievement wasn't a single feature. It was the decision to build an architecture that could adapt. By giving developers a choice, MySQL became more than just a database. It became a universal solution. So this whole story leaves us with a really powerful question, one that goes way beyond just databases. In a world where technology is constantly changing, maybe the most future-proof design isn't one that tries to guess what's next, but one that simply gives us the flexibility to build it.